Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get wrenching.
SOHC engine design scheme. One camshaft located in the upper part of the engine. Accordingly, there are 8 valves, 2 for each cylinder. The camshaft is driven by a belt. During operation, the belt does not require replacement, as the stated belt life coincides with the engine life. The belt tension is automatic and is built in by design. Fuel injection system with electronic control. Spark plugs are standard A17 DVRN. Spark supply is carried out by the ignition unit according to the scheme 2:2, i.e. spark is supplied to 2 cylinders at the same time improvements applied in the engine in order to ensure normal temperature regime. Of 95 C when using gasoline with octane number not lower than 95, the cooling system was modified. The area of the cooling channel cross-section was changed and the volume of antifreeze was increased. Changes were made on the internal channels of the engine head. To provide increased second antifreeze flow rate on the engine is installed pump from a 16-valve engine. In addition, the design of the thermostat has been changed. In order to reduce fuel consumption and improve engine reliability, serious modifications were made. The engine is installed lightened almost 40% compared to the engine VAZ 21114 connecting rod and piston group. This change allowed to reduce not only the weight of the engine itself, but, more importantly, reduced the inertia of the entire system. The constructive innovation allowed to increase the declared resource before overhaul. The exhaust manifold has elongated pipes and a larger resonator, which significantly facilitates engine breathing at the exhaust, as the aerodynamic resistance of the output path is reduced. The alternator mounting bracket has been changed to provide the possibility of adjusting the drive belt by applying an eccentric tensioner roller. This design is also used on VAZ Vesta car engines. Fuel used: the engine is designed to use fuel with octane number not lower than 95. The use of 92 gasoline, according to the manufacturer, is not allowed. Used oil: synthetic and semi-synthetic oils are used according to the data sheet and technical operation manual of the power unit. The use of mineral engine oils is not allowed. Oil viscosity is selected on the basis of climatic features of the region of operation. The first valve adjustment is performed after engine running in at TO0, then at 15,000 km at TO1 and then at 30,000 km intervals. At TO5, 75,000 km, the oxygen sensor is changed, and the alternator drive belt is changed at the mileage of 90,000 km. The average cost of the taking into account the inspection of other systems of the car without the cost of consumables does not exceed 5,000 rubles. After repair without replacing the main and connecting rod liners, the pressure in the oil system may drop and oil consumption may increase. It is not possible to determine whether the valves are bent when the belt is actually broken under operating conditions, as there is no open manufacturer's data on such a fault. Replacement of timing belt is not regulated by maintenance programs. Thrashing, ignition skipping. Failure of the ignition unit. The malfunction is caused by a defect in the unit itself. The block is unrepairable and must be replaced in its entirety. Valve knocking. It is a normal operational wear and tear. It is eliminated by selection of adjusting washers. The motor stalls at idle or in motion. The problem is with the electronic sensors that the motor is equipped with. Basically, the problem is solved by replacing the fuel mass flow sensor, DMRV, floating idle speed. The cause is a problem with the idle speed sensor or due to the presence of air suction in the brake vacuum booster. It is necessary to check the pipelines for damage. Increased idle speed. This fault indicates a burst crankcase gas suction line. engine modification and tuning options. As an option to increase engine power, it is possible to perform chip tuning in order to remove the ecological class limitation. The total percentage of power increase will not exceed 2 to 5%. Replacing the camshaft. It is not economically feasible, and neither is installing a turbocharger. Replacing the camshaft and receiver will remove 100 horsepower from the engine. If additionally to carry out modification of channels of a cylinder head, it is possible to win additionally 20 horsepower. To carry out such improvements, first of all, it is necessary to change the structural scheme of the engine from SOHC to DOHC. That is, it is necessary to replace the cylinder head with a 16-valve cylinder head with 2 camshafts. Such a replacement will increase the possible power of the 8-valve motor up to 120 horsepower without a significant impact on the overall life of the engine. In fact, refining the motor is reduced to remodeling it into a 16-valve version with the possibility of further refinement and increase in power. In conclusion, the VAZ 11186 engine stands out as a reliable and efficient power unit, particularly favored in models like the Lada Granta and Lada Kalina. With its standardized design and compatibility with manual transmissions, it offers a practical solution for everyday driving needs. Launched in the early 2000s, this engine not only meets Euro 4 environmental standards but also showcases a balance of performance and maintenance simplicity. Whether you are considering it for its technical specifications or its ease of use, the VAZ 11186 remains a solid choice for those seeking a dependable domestic engine. Thank you for watching, and we hope this overview has provided valuable insights into the VAZ 11186 engine.